All right, hey guys, we are going to review functions very quickly. All right, so remember, in order for something to be a function, it cannot have a repeating x value. So we're always just looking right here, okay? It does not matter what is over in the y value, because in order for it to be a function, it cannot have repeating x values. So when we look at this, we see we have 3, 5, 9, and 17. This could be a function. Okay, but when I look over here, I see I have 217 repeating x values. This cannot be a function. So is this a function? Yes, because I don't have any repeating x values. All right, now we want to look at a graph and determine if it's a function. The way that you're going to do this is, and when you're taking your SOL test, you have a ruler or you can even use your pencil too. Just slide it over. Do you see how this graph touches my pencil here and here? If it touches my pencil more than once, it is not a function. Okay, let's move it on over. Well, hold on. Let's see if I can send this to the back. Okay, so this is one thing that everybody was getting confused with. A straight line also cannot be a function because look, it touches my pencil the whole way through, okay? A straight line is not a function. Let's see if I can get my pencil back. Okay, when I look at this is only touching my pencil in one spot here. And if I move my pencil over right here, it's still only touching in one spot. This can be a function. These are not functions because it touches my pencil more than once. Okay, let's look at this one right here. Is this a function? No, because it touches my pencil, pretend that's my pencil, here and here. All right, now we're here. Is this a function? No, because it touches my pencil here, 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 and here. Let's look at this one. Is this a function? Okay, well, it only touches my pencil once right here. If I come here, it's only touching my pencil once. So yes, this can be a function. Now we need to look at when we're given points determining if it's a function. Remember, if they have repeating x values, here are my x values, right? If it has repeating x values, it cannot be a function. So when we look at this one, my x values are 2, 4, and 6. This is a function. When I look at this right here, I see that I have a 4 here and a 4 here. This cannot be a function because it has repeating x values. All right, I want you guys to look at this one first. Is this a function? Yes, because there are no repeating x values. Now take a look at this one. Is this a function? No, because I have a 1 here and a 1 here. Okay, now this. Is this a function? No, because I have a repeating x here and a repeating x here. Now let's review our domain and range. All right, so we're taking it old school, back to the alphabet. When we're given a set of coordinate points, just like the alphabet, x comes before y, okay? So in our set of coordinate points, we have x and then y. And just like the alphabet again, D is coming before R, right? So when I need to figure out what my domain and range is, I'll set it up like this. So what this is saying is that all of my x values are considered my domain and all of my y values are considered my range. In this set of points, my domain is 4 and -3. My range is 5 and 9. Okay, here my domain is -2, 8, 4, and 2, and my ranges are 9, 9, 7, and 5. When I need to identify domain and range by my tables, this is my domain. All of these values are my range. Okay? This is my domain. These are my ranges. Now we need to look and identify domain and ranges when we're given a graph. And what you need to do is you're going to have points, okay? And you need to determine what the domain and range is. Now, if I'm looking at this point right here, I need to find out the coordinate points. So I go to my x value first, which is -4, and then my y, 3. So my domain is -4, and my range is 3. This set of coordinate points is 3, 4. So that's my domain and my range. Take a look at this one. Okay. My coordinate points are going to be -3, -3. And the last one is going to be 4, -2. Now, one thing I do want to go over, and I forgot to add this in here, is when you are given a graph. Let's pull this down. Hide, go away. Why is this not letting? Here we go. Extend screen. Okay. When you are given a graph, and I have a point here, a point here, and a point here, it will ask you if this is a function. This is a function because they all have different x values. This x value is -4. This x value is -3. This x value is -2. But let's say I had another point right here. This is not a function because I have two -3x values. Okay, so look at this. I want you to tell me, is this a function? No, because I have two x values here and here. Okay? Is this a function? Yes, because here, if I look, this only has one x value, this has one x value, that has one, that only has one x value, this has one x value, and this has one x value. Right? Moving on. Let's look at this problem. This says, what is the range, here's a key word here, of the function f of x equals -3x minus 4 when the domain is -1, 0, and 1. Now, we know that in x and y coordinates, we know that this is my domain and this is my range, okay? We are given the domain. These are our domain values. These are x values. We have to plug these guys into this. Remember, when you are evaluating a function, the only thing you type in your calculator is what you see after the equal sign. So to do this, let's do it for this one right here, okay? So that's going to be -3, and in parentheses, well, that's not going to really work. I'll just use the green one. So I have -3, that is blue. There we go, -3, and in parentheses, I got to put -1. Whenever you plug in, you have to use parentheses, -4, okay? All right, guys, that's it. And how do I stop this?